All right, so this is question number 6 on the 2018 VCAA exam, and this one looks to do like a whole bunch of redox stuff because it says redox reactions here. So redox reactions occur in the human body as well as in electrochemical cells. This is this stuff here, don't really care. Write 2 half equations for this redox reaction. So here's the redox reaction here. All right, I need to write 2 half equations for this. I need to go oxidation and reduction. So what I'm going to work out is, first of all, I need to understand what is forming what. So this says that ethanol is converting into ethanol. So therefore, that's going to be an oxidation because that's what we know. This is one of the oxidation reactions that we should have an understanding of it. An alcohol turning it into an aldehyde. But also we can see that hydrogen is being lost in this conversion. So therefore, that would be a oxidation reaction as well. So what I'm going to do is oxidation is CH, if I get a pen that works, CH3, CH2OH, and that's going to be forming CH3CHO, and I need to balance this up. What am I missing? I've got the same number of carbons because it's both F. I've got 6 hydrogen on this side, only 4 on that side, so I need an extra 2 hydrogen ions because my oxygen is also balanced. I could already see that. And then 2 electrons negative on that side. In this redox half equation, I need to then look at my reduction is going to be NAD positive. That's going to form NADH there. And then I'm going to look at this because obviously that is forming that. My balancing will be a hydrogen ion on this side, and then I need 2 electrons on this side because I've got 2 positive on this side and 0 positive on that side, so my 2 electrons go on this side. So it's just about balancing redox reactions there. If I need to identify my reducing agent is my reductant, and that is the thing that is being oxidized. So in this case, my oxidation is this, so my reducing agent is going to be CH3CH2OH, or ethanol. Okay, it doesn't ask me to name it, just says me identify it, so therefore I could write the formula or the name there. But again, reducing agent is what causes the reduction to happen, so therefore the thing that is being oxidized is causing the reduction to happen. So therefore ethanol is my reducing agent. Moving on to the next part of this question, I've got here a Daniell cell, so a nice galvanic cell here. I'm just going to quickly look at what's going to happen here. I've got zinc and copper, so I'm going to go straight to my data booklet and look at those on my electrochemical series. I've already used this one something already, but I've got my copper here and my zinc, so every time I use my electrochemical series, I'm going to highlight exactly what I have. So what that means is my copper is my strongest oxidant, so that's going to be happening at the cathode, and my zinc is my strongest reductant, and that's going to be happening at the anode. So what I can see here is copper here is going to be the cathode, and that's going to be the anode, and I can annotate that already straight away. Question is actually to label the polarity of the electrodes, so using positive and negative. Being a galvanic cell, your cathode is going to be positive and your anode is going to be negative in this case. Okay, I can also see the fact that this is a galvanic cell because my two half cells are separated by a salt bridge, and I know it's not electrolytic. I can see that I'm measuring voltage and I'm not putting voltage into it or current into it, so therefore I know it's galvanic and not an electrolytic cell in that case. Over the page, use the electrochemical series to determine the theoretical voltage of this cell. So again, I go over here to my electrochemical series. I can see I've got positive 30.34 and negative 0.76. So what's the difference between these two? It's actually going to be, 1.1 volts, because it's a difference between positive 3.4 and negative 7.6. So it's going to be, 0.34, take away negative 0.76 equals 1.1 volts. So that's how we're going to look at that, the difference between those two numbers. The electrolyte in the salt bridge is potassium nitrate. In the box on the salt bridge, use the arrow to show my direction of my potassium ion flow. So let's jump back over to here. Now, being a galvanic cell, my potassium ions and my salt bridge is there to balance the charge. So electrons are going to be moving towards my cathode. So that means my negative charge is going to be built up on this side. So my potassium ions are going to flow towards my cathode. My cations flow towards my cathode to balance out the negative charge that is being gained there through the gaining of electrons in the reduction reaction. So that's there. Okay, list 2 visible changes that are likely to be observed in the Daniell cell when operating. So what's happening here is I know that my copper, being my cathode, is reduction. So let's have a look at what's going to happen here. My copper is going to be reduced. So therefore, I'm going to have a buildup of copper around that electrode. So I'm going to talk about that. Also, what's happening at my anode, my zinc is being oxidized. So what's going to happen is that's going to go corroding. So therefore, if I need to write something there, I'll say that at my cathode will become, I think this is shaking the camera a bit, larger, and the anode, my copper cathode, would be a bit more specific there, my zinc anode will degrade or get smaller. It will become larger due to copper forming on it for another area there, and my anode will degrade and get smaller as it's being oxidized. But we want to go observation, and observation is what we'll see. And I will see something become larger, I will see something become smaller. So therefore, that's what I'm going to write there. Rather than saying copper will be formed, well, copper I guess you can see, but you can't necessarily see the zinc being oxidized and being, so therefore you won't be able to see the zinc ions forming, so we can't write that. Visible changes, something you can actually see, is needed in that question. Now, what design features of the Daniell cell structure would allow it to produce electrical energy? Well, we need 2 marks here, so therefore I'm going to put 2 little dot points there. And so the first things first is it has a salt bridge to complete the circuit. So that's really important. And also, to produce electrical energy, we need to have the 2 reactants separated into 2 different half cells. So without the reactants being separated into 2 different half cells, you're just going to produce heat energy. To be able to produce electrical energy, that's why you need to actually move your cells away from each other and connect them via a salt bridge and a wire. We can probably talk about the external wire perhaps in there as well, but most importantly, I think this one's the most important one there, the fact that they're separated. And that, my friends, I believe is question 6 done. On to question 7 in the next video.